Hello and welcome to today's lesson on ultrasound. In today's lesson, we'll begin by understanding what ultrasound waves are. From there, we'll learn how sonar makes use of ultrasound for underwater exploration. Finally, we'll discover how ultrasound is applied for fetal scanning. So far, we have explored the properties of waves and their various forms. We have delved into different types of waves, including their frequencies and the wave equation. This knowledge has provided us with a solid understanding of how waves behave and propagate through different media. We have also looked at sound in great depth. Building on this foundation, we can now explore the practical applications of ultrasound. Ultrasound waves are sound waves with frequencies above 20,000 Hertz, which is above the range of human hearing. While we cannot hear ultrasound waves, they have powerful applications in various fields. In this lesson, we will explore the two key applications, sonar and fetal scanning. Sonar, which stands for sound navigation and ranging, is a fantastic use of ultrasound that helps us explore and understand underwater environments. Here's how it works. A sonar device emits an ultrasound signal. This signal travels through the water. When the ultrasound wave reaches the seafloor or any underwater object, part of the signal is reflected back towards the sonar device. The sonar device detects the reflected ultrasound waves, known as echoes. By measuring the time it takes for the echo to return, scientists can calculate the depth of the water. The longer the delay between the transmitted and reflected signals, the greater the distance to the sea floor. For example, if a sonar device emits an ultrasound signal and the echo returns after 1 second, it means the signal has traveled down to the seafloor and back up in that time. We know that speed equals distance divided by time. Hence, we can say that the speed of sound in water equals 2 multiplied by the depth divided by the time delay. This can be rearranged as shown. Depth equals speed of sound in water multiplied a time delay divided by 2. Knowing that the speed of sound in water is approximately 1,500 meters per second, we can calculate depth using this formula. Sonar is invaluable for detecting submarines, locating shipwrecks, studying marine life, and mapping the seafloor. With this established, let's now consider fetal scanning. Fetal scanning is a critical application of ultrasound waves in medical imaging, allowing us to create images of a developing fetus in the womb, also known as sonograms. Here's a detailed look at how it works. A handheld device called a transducer emits an ultrasound beam that is directed towards the mother's abdomen. As the ultrasound waves travel through the mother's body, they encounter the fetus. At each surface of the fetus, some of the ultrasound waves are reflected back, while others continue to travel through. The transducer also acts as a receiver, picking up the reflected ultrasound waves. A computer processes the reflected waves to create a detailed image of the fetus. This image helps doctors monitor the development of the fetus, check for abnormalities, and determine the due date. This approach to fetal scanning has some key advantages. First, ultrasound is non-invasive and safe, making it the go-to technology for routine prenatal care. Unlike X-rays, ultrasound does not use ionizing radiation, and therefore it poses no risk to the fetus or the mother. By understanding these two key applications, sonar and fetal scanning, we can appreciate how ultrasound waves are indispensable to our lives. In today's lesson, we delved into the fascinating world of ultrasound waves and their practical applications in sonar and fetal scanning. We began by understanding that ultrasound waves have frequencies about 20,000 Hertz beyond human hearing. We explored that sonar systems use ultrasound to detect underwater objects, measure water depth, and map the seafloor. We also looked at fetal scanning, where ultrasound waves create detailed images of a fetus inside the womb. In summary, understanding these applications of ultrasound waves underscores their versatility and significance in both exploration and medical fields. Watch the rest of the GCSE physics course at Sophos Education.